Here we are looking at a hypothesis test for a population proportion. So the problem says a decade-old student found that the proportion P of high school seniors who believed that getting rich was an important personal goal was 75%. A researcher decides to test whether or not the percentage still stands. He finds that among the 210 high school seniors in the random sample, 149 believe that getting rich is an important goal. Can he conclude at the 0.01 level of significance that the proportion has indeed changed? Okay, so we've highlighted everything that's important in this question right here. The first thing that is given to us here is the P. The proportion that we're guessing it is 75%. So this is what they believe. We want to see if it's changed. So they go out and do a sample, and they get 149 out of 210 seniors say that they do believe getting rich is important. This is our P hat. Okay, so we can go over to the calculator and do 149 divided by 210 and get that P hat is 0.7095. So we'll go a couple decimal places here just in case. So what we want to see is is that enough information to decide it's changed? So we can say that 71% is different than 75%, but we want to know for the whole population that if we went and asked every single high school senior, would it actually be different than 75%? So like, is 71% far enough away from 75% that we can conclude that by just asking 210 people? The other bit of information that we have here is the alpha, which is our level of significance at 0.01, so that may come in handy later. And then the word changed. So we would just want to know if it's changed. We don't care if it's less than or greater than. We just want to know if it's changed. Okay, so that tells us that we are going to use not equal to. So we kind of have the setup here. We should be able to start filling in some of these answers. So we want to know, is P equal to 0.75 or not equal to 0.75? So has it changed or has it not changed? So we are going to use what they call the Z statistic. Okay. So since we are looking at the Z statistic, we are doing a normal curve. So normal curve like this. And basically that's where our level of significance comes in. It's 0.01. So 0.01 means like 99% confidence level. So we want to know with 99% confident, is it going to change if we ask everybody? So this is way out on the curve here. And we're just going to leave a little bit of room here. We could do the 1%. So this green accounts for 1%. But since it's a two-tail test, we're actually going to divide it by 2 and get 0.005. So this green area right here accounts for 0.005 on each of these. So that may be handy when we come figure this out in a bit for our critical values. All right, so let's find the test statistic first to figure out where we fall. So our formula for the test statistic is kind of a crazy looking formula. P hat minus P over the square root of P times 1 minus P over N. All right, so we know what P and P hat are. The only thing we're missing here is N. N is the total number of people we asked. So the P hat is actually X over N. Okay, so our N is 210. The 1 minus P is just the 100%, the complement of P. So we could do 100% minus 75% is 25%. So P hat is 0.7095 minus 0.75 divided by the square root of 0.75. I'm going to go ahead and write 0.25 here because this is 1 minus 0.75, so that's 0.25, divided by 210. So again, what we're seeing, it is 71% set to 0.7095, enough different from 0.75 if we only ask 210 people. So this should be the test statistics that we're dealing with. So, okay, let's go to the calculator here. We are going to do 0.7095 minus 0.75. That's the numerator, so we're going to click equal, divided by the square root. I'm going to put this in parentheses because we have another numerator, 0.75 times 0.25 in parentheses, divided by our N, which was 210. And now we can press equals. So this should be our test statistic. Okay, our test statistic should be negative 1.355. Let's go to at least 3 decimal places. So we got that. Let's go ahead and fill these in while we're over here on this problem. So we have P is equal to 0.75 and P is not equal to 0.75. And we are using the Z test statistic. So now the last thing we need to find is our critical value. Okay. So if we jump back over here, our critical value, again, is this point right here. So that's why there's 2 blanks, because we have a two-tailed test. We need to figure out what that is. So we are just going to use the Z on the calculator, and we're going to do Z, we're going to do Z on the calculator, and we're going to do Z of 0.005. Now again, remember this only gives me the area to the right. So this calculator is only giving me this number right here, okay? So the area to the right. So this is our answer. To find the other side, it's going to be the exact same thing. It's just going to be negative. So this is going to give me the Z number, and this is going to give me the negative Z. So whatever number we got in the calculator, we're going to do the negative and the positive of that. So negative 2.576 and negative 2.576. One of those should be negative, one should be positive. So can we conclude that the proportion of high school seniors who believe that getting rich is an appropriate goal has changed? Well, let's go back to the picture one more time. So we know this number now is negative, I'm sorry, that one's positive. We know this number now is 2.576, and this one is negative 2.576. Our test statistic was negative 1.355. So that tells me that I fell within my range here, which means that we cannot conclude that it's going to be something different than 0.75. Okay, so this answer is actually going to be no. We do not think it has changed because we fell within our parameters here on our curve. So no, check. So don't make a simple mistake like me and put a negative in there. I had both negatives, so make one positive so we get the right answer. There we go.